Hello and good day to everyone. Today we will start our new topic of seismic interpretation. So in this video, I'm going to give you an overview of seismic interpretation and also hands-on practice on how we can do the seismic interpretation. So before we go into the detail, so we must need to understand what and why. So what is seismic interpretation? SI stands for seismic interpretation, and also importance of seismic interpretation. So let's look at the SEG wiki, which is the most popular website of geophysicists. So over there, if we look at the definition or what is the seismic interpretation, so the seismic interpretation is actually a science, or it's also can be an art of inferring the geology at some depth from the process seismic record. So the geophysicist actually helps the geologist, or they work together to do the geological interpretation in the subsurface with the help of the seismic data. So if you're going into the field, so you look at the geology, so you can know each and every formation and the features such as fault, fractures, folds, each and everything you can look at the surface because that is exposed. But in case of in subsurface, or if you want to look into some depth, then probably you have to look at the seismic record. So that is what is actually seismic interpretation. So the next question arises why we do the seismic interpretation. So actually the seismic interpretation can help to locate a lot of things such as groundwaters, minerals, mines, and also investigate the landfills and characterize how an area will shake during the earthquake. So if we are looking at the regional seismic survey, so that can help to look at the fault, fractures, or the active faults which has been going to be happens in near future. So that thing can help us to locate the earthquakes or how the earthquake will be happening because of which formation. And also, if we look at the deep seismic interpretation, which is the focus of our course, so the deep seismic interpretation is actually, or its primary use for oil and gas exploration. So if you look at the oil and gas industry, they are more focused on the seismic interpretation, which is more deeper, at least starting from 2 kilometer, maybe sometime is near also, but mostly the hydrocarbon can be mature at certain depth with certain temperature as well. So now we look at where actually the seismic interpretation comes into the life of seismic. So here is actually is a seismic life cycle. So it's a start with the acquisition. So you can look at this part. So we go into the marine, or as well as in case of land seismic, then we have to go into the field into the land to acquire our seismic data. So that is called the acquisition. Then the second step is processing. So in processing is a quite extensive task, and a lot of team members or teams works on the seismic interpretation. Then they come up with the subsurface geology or the image process. So once they already done the processing, then we have the seismic image. That is actually the geology of the subsurface. So in that section, we do the interpretation. So in interpretation, what we do, we pick the horizon, we have the fault interpretation. Then if in case we have some salt body or some other features, then we can do the interpretation here. After all the interpretation, then we can say, okay, it looks like your hydrocarbons is here based on your structural interpretation or stratigraphic interpretation, and also quantitative interpretation. So that is the part where your seismic interpretations comes in. So I will give you a very simple or the general overview of performing the seismic interpretation. So I have divided into three different steps. So the first steps is you have to plan your interpretation. So planning is very important because if you don't plan your project to be completed, then obviously you will not be having your target. So the first thing, you have to decide your objective. And the second thing is, you have to know the regional tectonic and the structural of the subsurface and the depositional trend, which you can get it from the geological studies of the area. So the first thing, you have to get the objective. The second thing, you have to be well versed with the geological knowledge of the area. And the third thing, in the first step, what seismic pattern should I be looking for? So either you are looking at the reflectivity, either you're looking at the fault, fractures, or if you're looking at the salt or gas cloud, whatever you are looking. So you must have to look at the pattern of the seismic. So you have to plan that one. So if we look at the second step of the seismic interpretation, so the second step is actually building and merging your data set. So the first thing is obviously your seismic data. It's either in 2D, 3D seismic data. Then the second thing is a well log. So the well log is very important because once you have your seismic data, then you can correlate your seismic with the well log to make sure that the depth of each reflectors and what you are going to interpret is the accurate formation which has been verified from the well logs. And the third thing, if you have some models, such as you have the geological model or velocity models, that can help you to interpret your seismic data. So the third steps for the performing interpretation is obviously the interpretation. So once you have done the well to seismic tie, then you can have the horizon picking, or either if you're doing the structural interpretation or stratigraphic interpretation, then you can look at the features which you are interested into picking. So a little bit explanation on the first thing when you are planning your interpretation. So an interpreter should clearly understand what conclusion are required from the data set. So either you are looking for the prospect maturation, or either you're looking on the structural interpretation only. And also you have to be very sure because the information is available in the seismic, it is important to focus maximum attention on extracting the data, pretend completing the object task. And the third thing is you must have to understand the seismic acquisition. So the data you're looking uh, at the seismic data, so you must have to get the basic understanding of the survey design, how the seismic data is acquired and what was the processing parameter, and a little bit on the regional tectonic, structural, and depositional trend, which is comes from the geological understanding. So here, the key point is that you have to get to know about the acquisition design as well as the processing parameter. The geological knowledge is obviously compulsory. So when you are doing your data loading or you're merging your data with the model, so then you have to be very careful because the seismic data of all vintage is made including P waves, shear waves, well logs, velocity survey, and VSP. So let's say in the field, if you have like sometimes you have only the P wave seismic data. So if you looking at the some special features such as gas cloud, then the shear waves can help you to locate the gas cloud. So the another thing when you are loading or building your models, then you have to look at the codes. If you have the well logs and you already have the codes, so you can have the paleontology or outcrop studies, and that data can gather and organize for integration with the seismic data. So let's say if you have the well logs at certain position at certain point, so each formation when you are picking, you can have the you can correlate with your cores with the paleontology report or the outcrop reports, which can be match, and it can help you to identify the hydrocarbons. So in some cases, we also use the gravity and magnetic data set to identify the location of the basement, such as salt bodies, igneous intrusive, and the shale masses. Obviously, the magnetic and gravity data does not help us to identify the reflectors on the formation, but at least you can have the mark of the basement, or if you have the very high acoustic impedance, or if you have some igneous intrusion which have some magnetic or the different gravity values from the rest of material, then you can identify or you can import that data set also. So in third part, which is the main interpretation. So in interpretation, the overall aim of the seismic interpretation is to add in constructing the most accurate earth model or the reservoir description possible. So that is actually our main objective. But before we doing that, so we have to do the process of interpreting the seismic data, eventually come down to the putting pencil to paper or cursor to screen. So in the previous time, if you look at 90s or 80s, so that time you probably have the paper and pencil, so you have to do the interpretation manually. But right now we are in the fortunate situation, so we have the uh, screen and all the digital data set. So the second thing, doing the interpretation, you have to do the value to seismic type. Then you have to start with the horizon and fault picking. Then based on that horizon, you can make the structure map with the faults or without faults. It depends on your objective. So you can have the depth structure map, because once you have the value to seismic ties, so once your seismic is in depth, or if you have the velocity model, then you can convert your seismic from time to depth. So that one also can give you. Then if you're looking at the fishes, so you can have the fishes map of reservoir, source, and seal analysis. And if you're looking for hydrocarbons, so there are some amplitude interpretation which actually give you direct hydrocarbon indicator, which is DHI. So thickness map is normally we use for reservoir estimation, the size of the reservoir. So that is also can be used for, this is a part of interpretation as well. So another thing is you can do is a fault interpretation or the fault plan maps. So once you have all the fault interpreted, then you can make in a plan, or it can be mapped accordingly. So the fault map with cross fault sands juxtaposition for seal analysis. So if you're looking at the seal rock, so you can have the fault plan. How does it correlate with the seal rock? Then obviously you can have the isochrone map and isopac. Isochrone is the same, similar in time, and isopac is in depth. So map can show the growth or thickening in a stratigraphic interval. So if you're looking at the certain formation, how thick is that? So you can have the isochrone and isopac map accordingly. So also you can have the seismic velocity map for lithology determination or the depth conversion. Sorry. So now I'm going to show one of the image, which is the subsurface image. So you can look at this subsurface picture. So you can see at the shallow part, you can have the very horizontal or the straight reflection. So the strata has been deposited quite smoothly. So you can interpret all. Like here, you have the yellow, red, orange, the blue, green, purple. All the horizon is quite flat, so you can interpret it easily. So this is uh, the and if you're looking at the deeper part, so you can see this is quite undulating surfaces, then it is followed by the fault and fractures. So it's a lot of these are major faults, and you have the small faults. Then you have the igneous intrusion, which is mostly this one. because of this igneous intrusion. Maybe this is a basement, so you can't see any reflection because you don't have the reflectors over here. So mostly our focus is in this sedimentary section. So we have the structure and stratigraphic feature so that we can interpret and do the accordingly. Then also we can do the stratigraphic interpretation. So it is one of the very good example. So over here you can see a lot of stratigraphic features you have. So and it can be followed by your well logs from here to here. Then in between you have a many sequence which has been deposited. So either you can have the HST, FSST, LST, and TST. So these are some of the system tracks. So once you have done the interpretation, pick the horizon. So you can plot all the surface maps to look at the subsurface depositional behavior. How does it look like? Like here you can see this is just like a anticline structure or the dome. So you can see this one was quite higher, then it's going like this. So on the top it's not deposit, I mean it's not appears this anticline structure. So now I will move to the our project uh, which has been identified to be completed for this task. So the general information about the data set will be used in this project. Actually, this is an open database. So the reference you can get from this F3 demo 2020 data set. So this data is from the country Netherlands and its location is offshore North Sea and the block name is F3. And if you're looking at the coordinates, so these are the coordinates for this data set. I will show you the location in the Google map. And it was acquired in 1987 and also it was processed in 1987, this data set. So if you look at the, just put your coordinates in the Google map, so you can get the position of the location. So this is actually the location of your block, which is in the territory of the Netherlands. So if you look at the another map, which is Google Earth, so in Google Earth, you can look at the real time or the real picture of the area. So this is all the UK, Netherlands, and we are looking at this area. So this is called the North Sea. So the tool which we are going to use for this seismic interpretation project is the PaleoScan. So the PaleoScan is one of the uh, intelligent software which can be used for seismic interpretation. So it has the auto tracking, auto interpretation, grid modeling, and a lot of feature which we are going to look into this features as well. So in this project, so I'm going to explain about the F3 seismic interpretation. So the first task or the tasks which we are going to perform are, first we are looking at the data loading. So in that we'll be loading our 3D seismic data, and I will show you how you can do this 2D seismic data. Then we will be load our well logs, and we look at the 3D horizons or 2D horizon, either way. Then I will show you how we can visualize our data set, such as we can look at our 2D data set, 3D data set, then how we can look at the horizons, then the time slices of our data. Then the beautiful feature of model grid interpretation of the PaleoScan, I'm going to show in the software how we can create and how we can choose the parameters of the model grid. Then we'll create the model grid on 3D dataset. Then another feature which is the horizon stacks. So in there we can have the ability to pick our top and base. So based on that, we can pick either in between the top and base you want to have the 10 reflectors or 100 reflectors, it's based on your choice. So you can have as much as reflectors you want to interpret in your seismic data. So then we'll be finishing our project with the seismic attribute analysis. So in which you will be looking at the multi-attribute application, such as RMS, coherence, and a lot of attribute I'm going to show you in that. So I think we will continue in the next video about the software and how we can load. We can start from the zero, how we load our data, and how to do the interpretation and follow all this stuff. Thank you so much.